Icebergs float in the cold waters of the polar regions, large pieces of ice that have broken away from glacier and ice shelves. They drift slowly with the ocean currents, moving through the water at a pace so gentle it is almost imperceptible. An iceberg is not something that appears suddenly. It forms over many years, as snow falls on land and accumulates in thick layers. The weight of the snow compresses the layers beneath, turning them into ice. Over time, this ice becomes part of a glacier, a vast river of ice that moves slowly toward the sea. When the glacier reaches the coast, pieces of it break off and enter the water, becoming icebergs. This process is calm and gradual, the ice releasing itself into the ocean in its own time. Most of an iceberg exists below the surface of the water. Only a small portion is visible above, while the majority remains hidden beneath. This happens because ice is less dense than seawater, causing it to float, but not by much. The ratio is such that about 1/10 of the iceberg's volume sits above the waterline, while the rest is submerged. The ice below the surface extends downward into the cold water, its shape often mirroring or continuing the form that can be seen above. The submerged portion is quiet and still, surrounded by the dark water of the polar seas. The ice in an iceberg is fresh water, not salt water. This is because icebergs come from glacier, which are formed from snow that fell on land. The snow never had contact with the ocean until the iceberg broke free and began to drift. This fresh ice can be thousands of years old, containing layers that were laid down long ago when the climate was different and the world was quieter. Some icebergs carry within them tiny bubbles of ancient air, trapped when the snow first compressed into ice. These bubbles are small windows into the past, holding atmosphere from centuries or even millennia ago. Icebergs come in many shapes and sizes. Some are smooth and rounded, their surfaces worn by wind and water into gentle curves. Others are jagged and irregular, with sharp edges and angular formations that catch the light in interesting ways. The shape of an iceberg depends on how it broke away from the glacier and how long it has been drifting in the water. Over time, the ice melts slowly, and the iceberg's shape changes. Waves lap against its sides, the sun warms its surface, and gradually the iceberg becomes smaller and its contours shift. This transformation is slow and peaceful, the ice returning to the ocean in tiny increments. The color of an iceberg is usually white or pale blue, though the exact shade can vary. The white color comes from air bubbles trapped in the ice, which scatter light and make the ice appear opaque. The blue color appears in ice that is more compressed and has fewer air bubbles. In this denser ice, light penetrates deeper and the red wavelengths are absorbed, leaving the blue wavelengths to be reflected back. This gives the ice a soft blue glow, especially in the parts that have been submerged or are in shadow. Some icebergs have bands or streaks of different colors, showing where different layers of ice meet. These variations are subtle and add to the quiet beauty of the ice. Icebergs drift with the ocean currents, moving wherever the water takes them. They have no control over their direction, no way to steer or change course. They simply float, following the slow movement of the sea. In the Arctic, icebergs may drift for months or even years, traveling long distances from where they first entered the water. Some move south into warmer waters, where they gradually melt and disappear. Others remain in the cold polar regions, circling slowly in the currents that flow around the ice caps. The journey of an iceberg is unhurried, a quiet voyage across the open water. The surface of an iceberg is sculpted by the elements. Wind blows across the ice, carrying tiny particles that wear away at the surface. Rain falls gently on the ice, creating small channels and depressions. The sun shines down, warming the ice and causing it to melt in places. All of these forces work together to shape the iceberg, creating smooth hollows, gentle ridges, and soft curves. The ice becomes a sculpture, formed not by human hands but by the slow action of wind, water, and sunlight. Each iceberg is unique, its shape determined by the particular conditions it has encountered during its time in the ocean. The temperature of an iceberg is cold, hovering around the freezing point of water. The ice itself is frozen solid, but its surface may be wet from melting or from waves that splash against it. In the air around an iceberg, the temperature drops, the ice cooling the surrounding atmosphere. This creates a small zone of cold air that travels with the iceberg wherever it goes. Birds sometimes rest on icebergs, standing on the cold surface or floating in the water nearby. Seals may haul themselves up onto the ice to rest, their bodies warmed by a layer of fat beneath their skin. The iceberg provides a temporary resting place, a platform of solid ice in the middle of the ocean. Icebergs can last for a long time, depending on their size and where they drift. A large iceberg in cold water may persist for years, slowly diminishing as it melts. A smaller iceberg, or one that drifts into warmer water, will melt more quickly, perhaps lasting only a few months. The melting happens gradually, the ice losing mass in small amounts each day. The water that comes from the melting iceberg is fresh, and it mixes with the salty ocean water around it. This creates a slight gradient in salinity near the iceberg, a zone where the water is a bit less salty than the surrounding sea. Marine organisms may be drawn to this area, finding nutrients or cooler water near the ice. The sound of an iceberg is mostly one of silence. Out on the open water, far from land, the world is quiet, and the iceberg drifts in this quietness. Occasionally, there may be a soft creak or groan as the ice shifts slightly, responding to the movement of the water or changes in temperature. These sounds are gentle, barely audible above the lapping of waves or the whisper of wind. Sometimes, small pieces of ice fall from the surface of the iceberg into the water with a quiet splash. The overall impression is one of stillness, the iceberg existing in a peaceful state as it floats through the sea. An iceberg is a transient presence in the ocean. It did not exist in its current form until recently, when it broke away from the glacier. Before that, it was part of a much larger mass of ice, connected to the land and slowly moving toward the coast. Now, as a separate piece, it drifts alone, gradually melting and becoming smaller. Eventually, the iceberg will disappear completely, its ice melted and its water mixed back into the ocean. This life cycle is calm and natural, the ice following a path that has been repeated countless times over the millennia. The water around an iceberg is cold, often just a few degrees above freezing. This cold water is home to organisms that are adapted to life in frigid conditions. Small fish swim in the water near the iceberg, their bodies equipped with special proteins that prevent their blood from freezing. Tiny crustaceans drift in the currents, feeding on even smaller organisms that float in the plankton. Seabirds fly over the water, occasionally diving beneath the surface to catch fish. The iceberg itself is not alive, but it exists within a living ecosystem, surrounded by creatures that thrive in the cold. Some icebergs carry sediment within their ice. This sediment was picked up by the glacier as it moved across the land, grinding against rock and soil. When the glacier reached the coast and pieces broke off to form icebergs, some of this sediment became trapped in the ice. As the iceberg melts, the sediment is released into the ocean, sinking slowly to the seafloor. These particles may contain minerals and nutrients that enrich the water, providing nourishment for marine organisms. The sediment is a reminder of the iceberg's origins on land, a connection to the mountains and valleys where the glacier once flowed. The light around an iceberg changes throughout the day. At dawn, the low sun casts a soft glow across the ice, highlighting its contours and making it appear almost luminous. During the day, the sunlight is brighter, and the iceberg's white surface reflects the light, making it stand out against the dark water. In the evening, as the sun sets, the light becomes warmer and softer, and the iceberg takes on a gentle golden or pink hue. At night, under the stars or the aurora, the iceberg is a pale shape in the darkness, barely visible but still present, floating quietly in the cold water. Icebergs are often found in groups, especially near the coast where glaciers are actively calving. These groups are not crowded or chaotic, but rather scattered across the water, each iceberg drifting at its own pace. The spacing between them is wide, and the overall impression is one of openness and emptiness. The ocean is vast, and the icebergs are small points within it, isolated and separate. They do not interact with each other in any meaningful way, simply existing in the same general area as they follow the currents. The ice of an iceberg is hard and solid, but it is also brittle. If you were to touch it, it would feel cold and smooth in some places, rough and textured in others. The surface might be wet from melting or from sea spray, and there might be small pools of water in depressions on the top of the iceberg. The edges of the iceberg, where it meets the water, are often rounded and smooth, worn by the constant contact with the waves. The ice is dense and heavy, and striking it would produce a dull, solid sound rather than a sharp or ringing tone. Icebergs are passive travelers. They do not move under their own power but are carried by the forces around them. The wind pushes against the part of the iceberg that is above water, and the current moves the part that is below. These forces may not always act in the same direction, which can cause the iceberg to rotate slowly as it drifts. The rotation is very gradual, often taking hours or days for a noticeable change in orientation. As the iceberg turns, different parts of it are exposed to the sun and wind, and the melting happens unevenly, which can further alter its shape over time. In the polar regions, the ocean is not always open water. In winter, sea ice forms on the surface, creating a solid layer that covers large areas. Icebergs can become trapped in this sea ice, held in place until the ice melts again in the spring. During this time, the iceberg does not drift. It remains stationary, locked in position by the frozen ocean around it. When the sea ice melts, the iceberg is released and begins to move again, resuming its slow journey through the water. This cycle of freezing and thawing happens every year, and icebergs may spend several seasons frozen in place before they finally melt away completely. The age of the ice in an iceberg can be estimated by looking at its layers and by measuring the isotopes it contains. Ice that formed long ago has a different composition than ice that formed more recently, and scientists can use these differences to determine when the snow first fell. Some icebergs contain ice that is tens of thousands of years old, ice that formed during a time when the Earth's climate was colder and glacier covered much more of the planet. This ancient ice is a record of the past, preserving information about the atmosphere and climate of long ago. The ice holds this information quietly, drifting through the ocean until it melts and releases its secrets back into the water. The presence of an iceberg can affect the local environment in subtle ways. The cold ice cools the air and water around it, creating a microclimate that extends for a short distance from the iceberg's surface. This cooler zone can attract certain species of fish or birds that prefer colder temperatures. The fresh water that melts from the iceberg dilutes the salt water, creating a layer of less dense water that floats on top of the denser seawater. This stratification can affect how nutrients are distributed in the water column, influencing the growth of phytoplankton and other microscopic organisms. These effects are small and localized, but they show how even a drifting iceberg is connected to the larger ecosystem of the ocean. Icebergs are most common in the polar regions, but they can drift far from their origins. In the past, icebergs have been spotted in waters much farther south than one might expect, carried by cold currents into temperate zones. These icebergs are unusual visitors, bringing a piece of the polar world into warmer latitudes. They do not last long in these warmer waters, melting quickly as they encounter higher temperatures. But for a brief time, they exist as reminders of the cold places far to the north or south, floating anomalies in an otherwise temperate sea. The volume of an iceberg can be difficult to estimate just by looking at the part above water. Because so much of the iceberg is submerged, the visible portion gives only a hint of the true size. A relatively small iceberg visible above the surface might be attached to a massive underwater structure that extends far below. This hidden mass is what gives the iceberg its stability and allows it to float upright. The submerged portion is shaped by the same forces that shape the visible part, worn smooth by the water and altered by melting, but it exists in darkness, unseen and unknown except to those who explore beneath the surface. Some icebergs have caves or tunnels carved into them by the action of waves and melting. These features are usually small and shallow, forming near the waterline where the ice is constantly being worn away. The caves are dark and cold, their walls made of slick, smooth ice. Water flows in and out with the motion of the waves, and sometimes small pieces of ice break off from the ceiling and fall into the water below. These caves are temporary, existing only for as long as the iceberg lasts. As the iceberg melts and its shape changes, the caves may collapse or fill in, and new ones may form elsewhere on the ice. The relationship between an iceberg and the ocean is one of exchange. The iceberg gives fresh water to the ocean as it melts, slowly diluting the salt water around it. The ocean, in turn, provides buoyancy to the iceberg, supporting its weight and carrying it along in the currents. Waves lap against the iceberg sides, wearing it down bit by bit. The ocean also provides a medium for the iceberg to travel, allowing it to move far from where it first formed. This exchange is quiet and ongoing, a continuous interaction between ice and water that lasts for the entire life of the iceberg. Icebergs do not have a beginning or end in the traditional sense. The ice that makes up an iceberg has been part of the Earth's water cycle for billions of years. It has evaporated from the ocean, fallen as snow, become part of a glacier, broken off as an iceberg, and melted back into the ocean, only to evaporate and begin the cycle again. The iceberg is just one stage in this endless cycle, a temporary form that the water takes before moving on to the next stage. The ice is ancient, but the iceberg is new, existing for only a brief moment in geological time before it returns to the sea. The texture of an iceberg's surface varies depending on how it has been weathered. Some areas may be smooth and glassy, polished by wind and water into a slick finish. Other areas may be rough and porous, with a surface that looks almost crystalline. There may be ridges or grooves where water has run over the ice, carving channels as it flows. In places where the sun has melted the surface, there may be a thin layer of water that refreezes at night, creating a delicate crust of new ice. All of these textures contribute to the unique character of each iceberg, making each one different from every other. Icebergs can be classified by their shape, though the categories are broad and somewhat informal. A tabular iceberg is one with a flat top and steep sides, resembling a table. These icebergs usually break off from ice shelves, which are flat expanses of ice that float on the ocean but are still attached to the land. A non-tabular iceberg has a more irregular shape, with peaks, valleys, and uneven surfaces. These come from glacier that have more varied topography. Within these broad categories, there is enormous variation, and no two icebergs are exactly alike. The shape of an iceberg is always changing as it melts and as different parts of it are exposed to the sun and wind. The density of ice is about 90% that of seawater, which is why icebergs float with most of their mass below the surface. This density difference is crucial for the iceberg's existence. If ice were denser than seawater, icebergs would sink, and they would not be able to drift through the ocean. Instead, they would settle on the seafloor and remain there until they melted. But because ice is lighter, it floats, and this allows icebergs to travel great distances and to exist as features of the ocean rather than the seabed. The physics of buoyancy determine the iceberg's position in the water, keeping it at the surface where it can be seen and where it interacts with the atmosphere. The life of an iceberg is one of gradual diminishment. From the moment it breaks off from the glacier, it begins to melt. The rate of melting depends on many factors: the temperature of the air and water, the amount of sunlight, the size of the iceberg, and the currents and winds. In cold water and cold air, the melting is slow, and the iceberg can persist for a long time. In warmer conditions, the melting accelerates, and the iceberg shrinks more quickly. But regardless of the conditions, the trajectory is always the same. The iceberg gets smaller and smaller until eventually it is just a small piece of floating ice, and then it is gone, melted completely and absorbed back into the ocean. Icebergs are silent monuments to the cold. They are made of frozen water, formed in places where the temperature never rises above freezing for long periods of time. They carry with them the coldness of the polar regions, bringing it into the ocean as they drift. This coldness is not just a physical property but also a quality that defines the iceberg's presence. To be near an iceberg is to feel the chill of the high latitudes, to sense the quiet stillness of a world made of ice and snow. The iceberg embodies this coldness, holding it within its frozen mass and radiating it out into the surrounding air and water. The study of icebergs has revealed much about the polar regions and the glacier that produce them. By observing where icebergs drift and how they melt, scientists can learn about ocean currents and water temperatures. By examining the ice itself, they can learn about the climate of the past and the processes that form glacier. Icebergs are natural laboratories, providing information that would be difficult or impossible to obtain any other way. The ice is a record, written in layers and isotopes, of conditions that existed long ago. As the iceberg melts, this record is released, mixing with the ocean and becoming part of the present. The ocean around an iceberg is often calm, especially in the polar regions where storms are less frequent than in temperate zones. The water is flat and smooth, reflecting the sky and the ice. The iceberg sits in this calm water like a sculpture in a gallery, surrounded by space and quietness. There may be no sound except the gentle lapping of small waves against the ice, no movement except the slow drift of the iceberg in the current. This calmness is profound, a stillness that seems to extend in all directions, unbroken by any disturbance. Icebergs have been observed and recorded by explorers and sailors for centuries. Early accounts describe them with a mix of fascination and caution, noting their beauty but also their size and solidity. Ships traveling in polar waters had to be careful to avoid icebergs, as a collision could damage the hull or even sink the vessel. Navigators learned to watch for the pale shapes on the horizon, especially in foggy conditions when visibility was poor. The presence of icebergs was a sign that the ship was entering cold waters, a warning that the climate was changing and that the conditions would be more challenging. The edge of an iceberg, where it meets the water, is a zone of constant change. Waves wash against the ice, wearing it away in small amounts with each pass. The water is cold but not frozen, and it dissolves the ice slowly, molecule by molecule. Sunlight warms the surface of the ice, causing it to melt and creating small streams of fresh water that trickle down into the ocean. This boundary between ice and water is active and dynamic, though the changes are slow and subtle. Over time, the waterline moves higher as the iceberg melts, and the overall size of the iceberg decreases. Icebergs have inspired artists and writers, who see in them a symbol of nature's power and beauty. Painters have captured their pale forms against dark water and gray skies, emphasizing their starkness and isolation. Poets have written about them as emblems of endurance and transience, things that are solid and real but also temporary and doomed to disappear. The iceberg's beauty is cold and remote, a beauty that does not invite warmth or comfort but instead inspires contemplation and a sense of awe. To see an iceberg is to be confronted with something both magnificent and indifferent, a piece of nature that exists without regard for human presence or concern. The composition of an iceberg is simple. It is water in its solid form. But within that simplicity is complexity. The ice contains air bubbles, dust particles, and sometimes even small rocks or sediment. It has layers that correspond to different snowfalls, each layer slightly different in density or composition. The ice has a crystalline structure, with molecules arranged in a hexagonal pattern that gives ice its particular properties. This structure is what allows ice to float, why it is slippery, and why it forms in the beautiful shapes we see in snowflakes and frost. In an iceberg, this structure is repeated billions upon billions of times, creating a solid mass that is both uniform and endlessly varied. The weight of an iceberg is substantial. Even a relatively small iceberg, one that might be only a few meters across, can weigh several tons. A large iceberg can weigh millions of tons, its mass concentrated in the dense ice that extends far below the surface. This weight gives the iceberg stability, allowing it to float upright and to resist being overturned by waves or wind. The weight also affects how the iceberg drifts, as the submerged portion is moved by deep ocean currents that may flow in different directions than the surface currents. The iceberg's trajectory is determined by the complex interaction of all these forces, each one pulling or pushing on the massive block of ice. Icebergs exist in a world of extremes. The polar regions where they form are among the coldest places on Earth, with temperatures that can drop far below freezing. The ocean is cold, the air is cold, and the ice itself is cold. Yet even in this extreme environment, there is life. Seals swim in the water, birds fly overhead, and tiny organisms drift in the currents. The iceberg is part of this ecosystem, a feature of the landscape that provides habitat and influences the distribution of nutrients and temperature. It is a reminder that even in the harshest conditions, life finds a way to exist and adapt. The future of an iceberg is certain: it will melt. There is no other outcome, no way for the iceberg to avoid its fate. From the moment it enters the ocean, it is on a path toward dissolution, and every day brings it closer to the end. This certainty is not sad or tragic, it is simply the nature of ice. Water freezes and melts, moving between solid and liquid states in response to temperature. The iceberg is a temporary arrangement of water molecules held together by the cold, and when the conditions change, the arrangement dissolves. The water that was once part of the iceberg becomes part of the ocean again, indistinguishable from all the other water in the sea. Icebergs can be found in both the Arctic and Antarctic, though the conditions in these two regions are somewhat different. In the Arctic, icebergs come from glacier in Greenland, Alaska, and other northern lands. In the Antarctic, they come from the ice sheet that covers the continent and from the ice shelves that extend out over the ocean. Antarctic icebergs can be much larger than Arctic ones, sometimes covering areas of many square kilometers. These massive icebergs are like floating islands of ice, drifting slowly through the Southern Ocean. They can last for years, gradually breaking apart and melting as they move through the water. The silence around an iceberg is occasionally broken by the calls of birds or the exhalation of a whale. These sounds are brief interruptions in the quietness, reminders that the iceberg exists within a living world. But the iceberg itself makes little sound. It drifts silently, its slow movement through the water almost imperceptible. The ocean is quiet around it, the air is still, and the ice is cold and unmoving. This silence is part of the iceberg's character, a quality that defines its presence in the polar seas. To be near an iceberg is to experience a profound quietness, a stillness that is both peaceful and slightly unsettling in its completeness. The visibility of an iceberg from a distance depends on the light and the weather. On a clear day with good visibility, a large iceberg can be seen from many kilometers away, its white surface standing out against the dark water. In fog or poor weather, an iceberg can be invisible until you are very close to it, appearing suddenly out of the mist like a ghost. The reflectivity of the ice makes it visible in daylight, but at night it can be difficult to see, especially if there is no moon or artificial light. Sailors in polar waters have learned to be cautious, knowing that icebergs can be hidden in darkness or fog, posing a danger to ships that come too close. The coldness of an iceberg is absolute. It is frozen water, locked in a solid state by temperatures far below the freezing point. Even in summer, when the air warms slightly and the sun shines for longer, the iceberg remains cold. Its surface may melt, creating pools of water and making the ice wet and slippery, but the interior of the iceberg stays frozen. The cold is deep and pervasive, a fundamental quality of the ice that does not change until the iceberg has melted completely. This coldness radiates outward, cooling the air and water around the iceberg and creating a zone of low temperature that travels with it wherever it goes. Icebergs are remnants of the Ice Age, though not in a literal sense. The ice they are made from may be old, but the icebergs themselves are contemporary, formed recently as glaciers reach the sea and break apart. Yet there is something ancient about them, a sense that they connect us to a colder time in Earth's history. Glaciers have existed for millions of years, growing and shrinking in response to changes in climate. Icebergs have been calving from these glaciers for just as long, drifting through the ocean in an endless procession. The iceberg we see today is part of this long history, a continuation of processes that have been happening for longer than humans have existed. The shape of an iceberg's underwater portion is often different from its above-water shape. While the top might be relatively flat or gently rounded, the bottom can have complex contours, with protrusions and hollows that are shaped by melting and by the movement of water. These underwater features are hidden from view, known only to those who dive beneath the surface or use sonar to map the ice. The underwater portion of the iceberg is in constant contact with the ocean, and it melts faster than the part above water, which is exposed to cold air rather than relatively warmer seawater. This differential melting can cause the iceberg's center of gravity to shift, and occasionally an iceberg will roll or flip, exposing a new surface to the air. The light that filters through an iceberg, if it is thin enough, has a quality unlike any other light. It is soft and blue, diffused by the ice and given a cold tone by the frozen water. This light is gentle and dim, creating a hushed atmosphere in any space it illuminates. If you were inside a cave in an iceberg, the light coming through the walls would be this pale blue, casting everything in a cool glow. The effect is ethereal and otherworldly, a reminder that the iceberg is made of a substance that is both familiar and strange, ordinary water transformed by cold into something beautiful and unusual. Icebergs drift at the mercy of the ocean. They have no agency, no ability to change their course or resist the forces that move them. They are passive objects, shaped and moved by wind, current, and wave. This passivity is part of what makes them fascinating. They are large and imposing, yet completely at the mercy of their environment. They cannot fight against the melting that will eventually destroy them, cannot avoid the warmer waters that will hasten their end. They simply exist, floating and drifting until they are gone. The ocean beneath an iceberg is deep and cold. In the polar regions, the water depth can be several thousand meters, extending far below the bottom of even the largest iceberg. The iceberg floats on the surface of this deep water, its bottom perhaps 100 meters below the waterline. Beneath it, the ocean continues downward into darkness, a vast space filled with cold, salty water. The iceberg is a surface feature, existing at the interface between water and air, while below it stretches an enormous volume of ocean that extends to the seafloor far below. The presence of an iceberg can be detected in various ways. Ships use radar to spot icebergs at a distance, the radar waves bouncing off the ice and returning to the ship. Satellites can see icebergs from space, their white surfaces contrasting with the dark ocean. Close observation can reveal other signs: a patch of calm water near the iceberg, a slight change in water color, or the presence of birds and seals that are attracted to the area. These signs help navigators avoid icebergs and scientists locate them for study. The iceberg itself is unaware of being observed, continuing its quiet drift through the ocean regardless of whether anyone is watching. Icebergs contribute to the ocean's water cycle in a small but measurable way. As they melt, they add fresh water to the ocean, slightly reducing the salinity of the surrounding water. This fresh water is cold, and it can affect local water density and circulation. In areas where many icebergs are melting, the input of fresh water can be significant enough to influence regional oceanography. This is a subtle effect, one of many factors that contribute to the complex dynamics of the polar oceans. The iceberg's melting is just one small part of the larger water cycle, but it is a part nonetheless, connecting the ice on land to the ocean and the atmosphere. The journey of an iceberg from glacier to open ocean is one of transformation. It begins as snow falling on a cold landscape, accumulating over years and compressing into ice. It becomes part of a glacier, moving slowly toward the sea under the force of gravity. At the coast, it breaks away and becomes an iceberg, floating free in the ocean. It drifts through the water, slowly melting and changing shape. Eventually, it melts completely, its ice returning to liquid form and mixing with the ocean. This journey can take thousands of years from the time the snow first falls to the moment the last piece of ice melts away. It is a slow, patient process, one that unfolds at a pace determined by nature rather than by any human timeframe. The iceberg is a natural sculpture, shaped by forces that have no artistic intent but which nonetheless create forms of great beauty. The wind and waves carve the ice into smooth curves and sharp edges, creating contrasts of light and shadow. The sun melts the surface in patterns that are random yet somehow harmonious, creating textures that are pleasing to the eye. The iceberg exists without purpose or meaning, yet it embodies qualities that humans find beautiful: simplicity, purity, and a kind of stark elegance. It is a reminder that beauty can arise from purely natural processes, without any need for conscious design or intention. An iceberg floating in the ocean is both permanent and temporary. It is a solid object, a real thing that occupies space and has weight and substance. Yet it is also transient, existing only for a limited time before it disappears. This duality is part of what makes icebergs compelling. They are undeniably present, impossible to ignore when you see them, yet they are also fleeting, destined to vanish. They embody the idea that all things are temporary, that even the most solid and substantial objects will eventually change and cease to exist in their current form. The iceberg is a meditation on impermanence, a frozen sculpture that will not last forever. The ocean in which the iceberg drifts is vast beyond comprehension. It stretches to the horizon in all directions, a seemingly endless expanse of water. The iceberg is a tiny speck in this vastness, insignificant in size compared to the ocean that surrounds it. Yet from the iceberg's perspective, if it had one, the ocean would be everything, the medium in which it exists, the force that moves it, and ultimately the substance into which it will dissolve. The iceberg and the ocean are made of the same thing, water, differing only in temperature and state. They are connected in a fundamental way, part of the same system, the same cycle of freezing and melting that has been going on for billions of years. The final moments of an iceberg's existence are quiet. As it gets smaller, it loses stability and may break into smaller pieces. These pieces continue to melt, becoming smaller and smaller until they are just fragments of ice floating on the surface. Eventually, even these fragments melt away, and there is nothing left but the cold water where the iceberg once was. There is no marker, no sign that the iceberg existed. It simply returns to the ocean, its substance mixed with the vastness of the sea, indistinguishable from all the other water. The iceberg is gone, but the water remains, ready to freeze again in some distant future, to become part of another glacier, another iceberg, continuing the cycle that has no beginning and no end.